Eco-Modernist podcast. Our philosophy is based on sound science and free from the outdated dogmas of the 20th century.
Hi, this is Gabe Rick.
And this is Rick Maltese.
And this is the Eco-Modernist podcast. We have as our guest today Dr. Ken Caldeira. Dr. Caldeira has served as a member of the committee producing the 2015 U.S. National Academy of Sciences report on geoengineering. He is a contributing author to the 2013 IPCC report on climate change and their 2005 report on carbon capture and storage. He is presently a climate scientist at the Carnegie Institution of Science, a fellow at the American Geophysical Union, and professor in the Stanford University Department of Earth Systems Science. In short, Dr. Caldeira is arguably one of the leading minds on the planet on both our global climate crisis and its solutions. Dr. Caldeira, welcome to our show.
Good to be here.
Let me be the devil's advocate for a minute. There's a meme that's popular on the internet emanating from climate deniers against the scientific consensus on global warming, that science is neither infallible nor is it a democracy.
Well, science is not a democracy and it is fallible. So, like Scott Pruitt, for example, has been suggesting doing this red team, blue team thing on a televised debate. That's how you can settle science. And science is an iterative process where people publish work and then other people try to tear it down, and occasionally bad stuff gets published, but the hope is eventually that stuff will get discounted.
Perhaps climate skeptics' biggest objection to climate action is that they are taken aback by the degrowth message coming out of the environmental movement, and therefore believe that a wait-and-see attitude is better than drastic action, which would reduce us all to living in what they call a green gulag. In short, they question why strong climate action is needed unless and until the question of its necessity is decisively settled. On the face of it, that seems quite rational. What is your response?
Yeah, well, there are a few different questions wrapped up in that question. One is about the risk of uncertainty. Let's first address this question about sacrifice and the messaging there. There are different threads in the various communities that want to address the climate change problem. And one of those threads is built on the idea of sacrifice, that if we deny ourselves energy and get people to avoid doing things that they like doing, that is the path to solving the climate change problem. And then there's another thread, which I think this Eco-Modernist podcast is probably well aligned with, that says, well, really, we need to figure out a way to provide abundant, environmentally friendly energy and look more to high-tech solutions rather than asking people to practice self-denial. And I guess there's this similar kind of messaging in the basic idea that right now carbon emission-free energy is more expensive than, say, burning coal or natural gas. And so there's this idea of, we're going to have to sacrifice and spend a little in the present to help the future. And that's a tough sell. The other point you raised was this issue about uncertainty, that there are people who act as if uncertainty is a reason not to act, as if not being sure that your house is going to burn down means, I don't have to bother installing smoke detectors or clear brush around the side of my house. And so the idea that just because there's a risk of something and not a certainty of that, you don't take precautions. But of course, climate change isn't all about risk. The central expectation of what's going to happen is bad enough.
Dr. Caldeira, I've heard it takes roughly 40 years for CO2 in the air to express itself as climate change. So what if there was some global event that shocked the world into decisive action? Would we still be locked into a far worse outcome decades later, even if we were to go cold turkey completely and immediately stop our use of fossil fuels?
We did some simulations that suggested that delay could be as little as 10 years. And so even if it is 40 years, you're probably getting 3/4 of the response to a CO2 emission within the first decade. So to me, while there are time lags in the climate system, and those time lags are important, the bigger time lag is really what's the time lag associated with an energy system transition. These days, if you can site a coal plant or a gas plant somewhere, plants are so difficult to site that once they're sited, people want to keep renovating them and keep using them just because of this sort of NIMBY, not my backyard, difficulties in getting new power plants built. You already have power lines and train cars and pipelines and things coming into that site. So it's typically just cheaper to keep an existing site going than to create a whole new facility. Václav Smil has done lots of work in this area, kind of showing historically that energy system transitions are typically century scale activities. And, if you build a power plant today, that power plant's likely to have a lifetime of 75 years or more. So we're building the power plants of the 2090s today. So I guess I'm more worried about infrastructural lock-in and delays associated with infrastructural transition rather than the physical climate system.
The 100% renewable meme has been coming under growing scrutiny as 21 prominent scientists recently issued a sharp critique of one of your colleagues at Stanford. Mark Jacobson claims that we could easily become 100% renewable by mid-century. He has refused to acknowledge sound scientific principles in his research and address major errors, which have been repeatedly pointed out by the scientific community. Do you agree with that assessment? And what role do you see for renewable energy going forward?
First of all, I was a participant in that author group that produced that critique. If you look at, say, the IPCC report, I forget it was 2013 or 2014, IPCC Working Group 3 mitigation, it looked at the broad spectrum of energy technologies that could contribute to getting rid of greenhouse gas emissions. And they showed that using a broad spectrum of technologies made the problem easier to solve. Maybe in 2015 or so, there were two important reports, one from the National Renewable Energy Lab, a branch of the U.S. Department of Energy, which did a deep emission reduction scenario of the electric sector. And they concluded that about 80% of the emissions could be eliminated if you had a giant fossil fuel backup system to run when the wind wasn't blowing or the sun wasn't shining. And then NOAA did a study involving this guy McDonald and Chris Clack, and they also did an electric sector simulation of the United States and showed that with natural gas backup, you could get something like an 80% reduction with continental scale high voltage DC electric grid. So I think there's a couple of things to be aware of here. First of all, the current end-use energy that comes from fuels as opposed to electricity, the fuels energy use is several times bigger than the electric energy use. So if you've managed to decarbonize the entire electric sector, you've only solved less than half of the problem. And everybody knows that the problem with intermittent renewables like wind and solar is that if you had something like a month of energy storage, then you could cost effectively use those approaches as your electric backbone. But sometimes there can be a 2-week period where essentially no wind is blowing in the entire United States. And so you need something like 3 weeks of storage in order to make it work. And so what Mark Jacobson did in his study is just kind of assume that we had abundant free storage or almost free storage. And he kind of showed that, if you had abundant free storage, that you could get by with intermittent renewables. But everybody knew that already. And the problem is there is no abundant free storage. And so what Mark Jacobson did is basically a what-if experiment. What if there was abundant, nearly free energy storage? And also a few other assumptions, like what if we could make airplanes run on hydrogen and basically use hydrogen as our only fuel? So basically, if you had abundant free storage and you can make hydrogen-powered airplanes and so on, then you could solve the climate problem. But first of all, there's just not abundant free storage. In his simulations, he needed an amount of hydropower equivalent to the flow of 100 Mississippi rivers, and he needed airplanes to be flying on hydrogen, which just doesn't exist because of low power and energy densities. So basically, it was a thought experiment, which was then presented as if it were a concrete plan for action. And meanwhile, there have been thousands of energy system analysts doing detailed work over the decades saying, why does this back of envelope calculation get so much play when there's so much detailed analysis that goes in the other direction? And the politics of it, or the sociology of it, is kind of interesting because when it comes to climate science, if you have NOAA, DOE, and the IPCC climate scientists saying something, and then you have one academic somewhere publishing a paper saying, oh, no, the IPCC, Department of Energy, NOAA all have climate science wrong. I'm the one who understands the world and everybody else is an idiot, that people would just discount that person. But somehow when it comes to energy technologies, when you have one person saying the IPCC and all these other thousands of scientists who've worked for decades in this area are wrong, they just somehow grab onto that one paper because that one paper says what they want to hear. And in the same way that the sort of right-wing nuts will latch on to a climate science denier paper opposing thousands of other papers, sometimes people on the left can act the same way and latch on to that isolated paper that says what they want to believe. But yeah, I think as scientists and technologists, it's an issue about what's practical and what's feasible in the real world.
I recall reading about hydro dams and how they could be increased in their capacity and that it was a mathematical mistake.
Yeah, apparently they had never checked what the rate of power extraction from their dams were in their model, and apparently they had no constraint on that. And they were assuming that for several hours at a time, you could provide more than the amount of electricity currently provided by our total country's electricity system from hydropower alone.
I have a couple of questions. You mentioned that the transport sector in general uses twice as much energy as the electric grid. Are you saying that he did not factor in the transportation sector in his report?
He made the assumption that most of the transportation sector could be electrified, which is probably true of local automobile type traffic, that whatever in the transportation sector can't be electrified could be made to run on hydrogen. Hydrogen, even if compressed to high pressure levels, only has something like 1/3 the energy density of aviation fuels. It's just not practical to run intercontinental aviation on low density fuels. You might be able to get a Los Angeles to San Francisco flight working on hydrogen, but you're not going to get San Francisco to Sydney working on hydrogen.
My next question is this. I have heard that Mark Jacobson's report does not factor in population growth and also doesn't factor in economic growth across the planet, especially in the developing world. Is that true?
Well, several times in the past when we said, oh, you didn't consider XYZ, they come back saying, oh, well, we did consider XYZ. It just was written in some kind of secret code in the paper, and that's why you weren't able to see it. And so you really need to ask them. My understanding when he pointed out about future population growth, that they assume that efficiency improvements will reduce per capita demand. I mean, we've done some calculations ourselves in an idealized modeling framework. And I think the basic issue with Mark's calculations are really this assumption of abundant cheap storage. Because if you have abundant cheap storage, you can have as variable a source as you want, and then you put it all into the storage, and then you pull it out of the storage when you need it. And so if you allow people to have abundant, cheap storage, then yes, you can use intermittent power sources. And all the other little things that you can criticize Jacobson's work for are really subsidiary. Storage costs a couple $100 a kilowatt hour per battery or some other kind of storage. And if we could bring that to $1 a kilowatt hour, which nobody thinks we can, then he would be right, basically. We're going to make storage 100 times cheaper than it is today.
There's been many authors and teams of people that have produced papers in response to Mark Jacobson's report. Were you involved in any of these critiques?
I co-authored a recent paper by Chris Clack that was published in the Proceedings of the National Academy of Sciences that critiqued Jacobson's 2015 paper in that same journal.
Let's talk a little about sea level rise. Just last week, an extremely large chunk of ice the size of Delaware broke off from Antarctica. What are we up against here as far as our ability to stabilize the breakup of the Antarctic and our ability to adapt to and mitigate sea level rise?
We published a paper a couple of years ago addressing the question of what would happen if we did not curtail our carbon dioxide emissions, if we just continued burning fossil fuels. And eventually, all of Antarctica melts. So that's about 60 meters, almost 200 feet of sea level rise. Now, it does take a few thousand years, but in our model projections, the average rate of sea level rise over the next 1,000 years was something like an inch a year, something like 3 centimeters a year, so something like a foot a decade or 10 feet a century. And we'll probably see a little bit less than that this century, but a foot a decade is a pretty healthy pace for sea level to be rising. It's going to generate a lot of political discussion. You know, you can see after Katrina, there was a little bit of discussion saying, well, look, we know we're going to lose New Orleans sooner or later. Is now the time to think about withdrawal from the coast? And nobody wanted to do that. Everybody just said, okay, let's rebuild New Orleans. And anyway, we're going to be in for a state of coastal retreat. And it's one thing if you're a rich country, and if you're in the United States, and we could think about losing New York City and Miami and New Orleans and Houston and all the low-lying cities. But if you're in Bangladesh or someplace like that, you don't have an economy that can stand up to that loss.
There's been a recent article in The Independent which quoted Professor Nancy Bertler of the Antarctic Research Center at Victoria University as saying that a catastrophic collapse of the West Antarctic ice sheet could raise global sea levels by 3 meters. That translates to over 10 feet of sea level rise in this century. How likely is this, and can anything be done to slow or stop it?
Well, there are some catastrophic scenarios of big ice sheets breaking up fast and getting a couple of meters, say 10 feet of sea level rise this century. I don't think that's the central expectation, but I think those kinds of rates of change are expected in the centuries to follow. But in terms of what you can do, I mean, the basic story is stop emitting greenhouse gases, and then I guess there's potential for geoengineering things.
Dr. Caldeira, what do you think is the timeline before people in cities like New York or Miami would face the necessity of moving inland?
Well, I'm from New York, and so I was thinking about this, and what if sea level's going up 10 feet a century? Then I could imagine New Yorkers just hardening the bottom of buildings and making floating sidewalks and say, we're going to lose a floor a century, but we can deal with that. But of course, there's this infrastructure of all this electric system underground. And I don't know whether in 1,000 years or 500 years, is New York City going to kind of be like a Venice with skyscrapers sticking out of the water, or are they just going to abandon it and it'll be a place where people take boat trips on vacations to see this ruins, and maybe you go there for scuba diving? I don't know, but I think Katrina and Sandy are the kind of beginnings of what we're going to see a lot more of. Sea level rise doesn't hit coasts so much on the average. It's that the storm surges are higher and then become more frequent. And so first, the impulse is going to be to protect yourself against these storm surges and build bigger levees and dikes and things. And already in the Netherlands, they're thinking about floating structures. So as sea level rises, build a house on a barge and the barge just kind of rises. And who knows what people will do, but it's hard to imagine people abandoning New York City. And so what kind of technologies will people develop to allow a city to be submerged in water? I don't know.
I guess you heard about Chicago being raised a few feet in the 1800s when they needed to put in a sewage system?
Around San Francisco, where I'm living now, a lot of San Francisco was landfill, and they dredged gravel and so on out of the bay and built up the land. And you could imagine San Francisco airport, something that's high value like that they put another 2 feet of dirt on top of it. I mean, people already live from the equator to the Arctic Circle, and so we're pretty adaptable.
What about the problem of heat stress? Could that cause massive crop failure or worldwide famine?
If humans were good problem solvers, we could deal with it. Crop models under climate change show reduced crop productivity in the tropical areas, but increased crop productivity in places like Siberia and Canada, where you're getting longer growing seasons and the CO2 fertilization is benefiting the crop growth. I don't think anybody has to go hungry in a climate change world if food distribution were equitable, but people are going hungry in today's world already. And if we were good at solving problems, we would solve the climate problem. I guess I see a lot of the risks from climate change as a combination of some change in the physical system and then an inability for our political and social systems to deal with those changes properly.
Let's talk about ocean acidification. Do you consider ocean acidification to be more or less of a threat than global warming?
I think overall, I guess a threat to whom or what? Ocean acidification makes water more corrosive to calcium carbonate minerals, and a lot of things like coral reefs and clams and so on make their shells and skeletons out of calcium carbonate. I think it's likely that a combination of ocean acidification and global warming will mean that within a few decades, there's no sustainable reefs left on this planet. The warming and the acidification are a critical threat. I think the nearer term threat is the warming, but if the warming doesn't kill them off, the ocean acidification will. Wherever there's light and nutrients, something will grow, and wherever some plants are growing, something will eat it. Sort of have confidence in humans to find something in there that humans can eat. So I think that ocean acidification is going to be a giant threat to biodiversity in the oceans, but I don't think it represents any kind of fundamental existential threat to human beings. Climate change is a big threat to existing ecosystems and biodiversity, but I look at people as being a lot like rats and cockroaches that are able to live in all kinds of environments and adapt to anything. But the poor people who are living in hot places and unable to grow their crops, to them, climate change could be an existential threat.
This is speculation, but my fear is civilization suffering the death of 1,000 cuts.
I guess I don't pretend I can see the future, and I can think of different possible outcomes. Let's first start with utopian type or quasi-utopian visions. So one vision is, okay, we don't do anything to stop climate change, but the world gets rich. This is sort of the cartoon version of Bjorn Lomborg's vision. The world gets rich, and basically Houston and Miami are the model for the developing world. People have air-conditioned homes, they go to their air-conditioned car, and then go to the air-conditioned shopping mall and their air-conditioned work. And basically in the summer, just nobody goes outside. If everybody's rich enough that you basically bring your economy indoors. So that's the sort of utopian vision. I guess the other sort of utopian vision is that we all sing Kumbaya together and decide to spend some more money on our energy systems, and we avoid more greenhouse gas emission and don't have the climate change problem. Yeah, and the danger is, what if we continue emitting greenhouse gases and the world doesn't get rich? Places like India, which have high population density and are already very hot and humid, could become very unpleasant to be outdoors in during the day. There are nearly 5 billion people in Africa by the end of this century. So the question of how do you get 5 billion people in Africa and get them all rich and air-conditioned, that seems like quite a challenge. I mean, it's hard enough to get 5 billion people and have them all well-fed and sheltered and educated. But if they don't get rich enough, the potential for climate migrants is huge. Population of Lebanon is 4 million, and they have 1 million Syrian refugees. And so basically the refugee population in Lebanon today is 1/4 of the local indigenous population. And, the idea that our societies could be asked to take in migrants at that level is a huge disruption. I don't have the exact numbers, but let's say Germany's on the order of 100 million people, and they took in 1 million migrants, and that was a 1% level that they're having difficulty assimilating. So you could imagine who had 10 or 20 times that level of migration. Rich people can live in gated communities and hire sentries to keep the teeming masses out of their gates and so on. But it could be an existential threat to the rich person if there's mass migration and people start storming the barricades.
There has been alarm within the scientific community concerning the ocean's lessening ability to both sequester carbon dioxide and to produce sufficient oxygen over time to support life on the planet. Could you break this down for us?
Yeah. Well, plankton and plants do produce oxygen when they photosynthesize. When they die, they rot, and in that decomposition process, they take up oxygen. And so really the oxygen that's in the atmosphere is not from living plants, but it's more from coal and oil and other carbon that's buried underground, that oxygen that used to be associated with that carbon is now in the atmosphere. And so it's really the burial of reduced organic carbon that leaves oxygen in the atmosphere, not just the photosynthesis. Well, here's something to put it in context. The atmosphere is, I think, something like 21% oxygen. It's only 0.04% CO2. One way of looking at it is that by burning the CO2, we burn 500 times as much carbon as we've burned in order to use up the oxygen in the atmosphere. So I think the issue about oxygen in the ocean is more about the ocean makes oxygen less soluble, and marine organisms have more trouble breathing in warm waters or getting oxygen through their gills. And so I would say the bigger oxygen concern right now is what's the lack of oxygen going to do for marine life. But I'm not worried about me or any of my progeny. You could basically get rid of all the rainforests and sterilize the oceans, and we would have no trouble breathing for millions of years. So this is not a concern.
I have some thoughts from Dr. Peter Wadhams, professor of ocean physics at the University of Cambridge in 2013, that I'd like to share with you.
There's been a joint Russian-Alaskan expedition going out into the Siberian Sea, and they've been seeing great plumes of methane bubbling up all over the Siberian Sea. The whole zone of millions of square miles of territory is now releasing all of its methane cover.
At the moment, we have to rely on Shakova and Semiletov, and they have then expert knowledge of the seabed conditions, and they're the ones who are estimating 50 gigatons of methane. So that could be revised up or down if further work is done in that area.
And do you think civilization could survive a 50 gigaton release of methane?
No, I don't think it can. I think that if you look at the existing predictions of global warming rates, the business as usual projections, even the cautious ones produced by IPCC, are still giving us about 4 degrees of warming by the end of the century. If you get to 4 degrees, then collapse of civilization is what's going to happen. And now with this Arctic methane, you're simply adding another element to the warming that brings forward the date at which catastrophic warming is achieved by maybe another 20 years.
What is your assessment of all this? Let me ask you quite frankly, does civilization have an expiration date of 2080? And is it possible that human extinction is the ultimate end game in all of this?
Yes, my sense is that Professor Wadhams is a little too extreme and goes beyond where the evidence is. I guess one could say that he might be presenting some worst-case scenario that might possibly happen, and the fact that it's just a worst-case scenario maybe is reason enough to take it seriously. But if you ask, what do people actually expect? First of all, that methane is a very good energy source. And so if methane's pouring up through the soils, there's all kinds of soil microbes that like to eat it. And if it's bubbling up through the ocean, most of it will likely dissolve in the water column and get eaten and be released as carbon dioxide, where it might be something like a 10% amplifier. And so there is a risk that high amounts of methane would come out as methane. But most of the mechanistic models of that system don't predict that. I would say even if there's a 1% chance that Wadhams is right, that may be a reason enough to curtail our greenhouse gas emissions. But again, I take a much more gradualist view. I tend to think that climate change will make things get gradually worse and worse, and that most of these real catastrophist scenarios I don't see as happening.
So you're not as alarmist as some people out there.
No, I actually get in trouble from both sides on everything because I say things the way I see it, and often that's not alarmist enough for some people who are very alarmed, which I'm alarmed, but maybe not as alarmed. And then I actually end up agreeing with some of the things that some of the more right-wing or denialist type people say. And so I managed to make enemies on all sides, which means that's probably okay.
You have been the co-author, along with James Hansen and other prominent climate scientists, of an open letter to policymakers calling for an enlarged focus on nuclear energy in the ongoing Paris climate negotiations. Let me ask you this. It's been often said that nuclear energy is unnecessary because renewables could supply enough energy to deal with the climate crisis. Even assuming that this were possible, is there really such a thing as having enough energy to take on this and other global threats?
So, if there were no such thing as nuclear energy, we wouldn't say, oh, game's over, we're going to just have climate change now. So take any technology off the table and we could still solve the problem. And the issue is, how hard are we making it for ourselves? And there's only a few kinds of primary energy in the world. There's solar, there's the wind, there's fossil fuels, there's nuclear, I guess there's hydropower. And you have this giant problem to solve, and now we're going to take one of the few things that we know of that can provide abundant, reliable electricity and take that off the table. And if I had to say, what is my biggest hope for solving the climate problem? It's that the Chinese will figure out how to make modular reactors on an assembly line, and they'll make them cheap. And basically, if there's cheap enough modular reactors that somebody can just buy off the assembly line and install somewhere, that seems like a very plausible way we could solve the climate problem. And you could imagine these could be closed vessels, so they get shipped back to China for reprocessing or who knows what. The ultimate thing would be if somebody could make a carbon neutral energy source cheaper than coal or natural gas and then just let the market take over. And I think even though nuclear is expensive today, it doesn't seem like there's an intrinsic reason why it needs to be more expensive than coal. When solar photovoltaics were very expensive, everybody's saying, oh, let's do R&D to bring down the cost. But when nuclear is too expensive, people say, oh, let's throw that away because it's too expensive. And it seems like we should have the same kind of desire and drive to bring down the cost of nuclear that people had with photovoltaics.
Let's move on to another area of expertise that you have under your belt. What do you think of the attitudes and policies that exist concerning geoengineering?
There's two main categories of what people call geoengineering. One is this idea of carbon dioxide removal, and the other is reflecting sunlight. And it's really, for the most part, this reflecting sunlight back to space that has the potential to cool the Earth rapidly. Climate model simulations show that these approaches, at least in the models, can offset most climate change for most people most of the time. And that seems to me that we really want to have these technologies develop so that if Wadham's scenario of methane pouring out of Siberia really comes true, or if it really looks like Antarctica is going to break up rapidly, that you have something to do. The more likely scenario that there starts being widespread famines throughout the tropics because heat stress is preventing people from being able to grow their crops, that if you have a real catastrophe with millions of people dying, solar geoengineering is the only thing you can do that would cause the temperature to decrease within our lifetimes. The warming from our past emissions are baked in and will be around with us for many centuries. And so solar geoengineering is the only thing we can do to reduce temperatures within a politically relevant time frame. And so if something bad really happens, I think there could be intense pressure to deploy these systems. And so we should really understand them now. So I'm a strong advocate of the research and development of these approaches. I think it would be premature to deploy them.
Probably the safest form of geoengineering is carbon sequestration. What is the potential of carbon sequestration at this point in time and in the future? Do you see any possibility of our being able to actually reverse our carbon footprint in time to avoid the projected worldwide calamity?
Yeah, the main problem with carbon dioxide removal is that there are no big wins there, that each CO2 molecule needs to react with another molecule or ion. And so whatever you do has to be of the same scale as our energy system. And so it just seems to have like one energy system putting carbon dioxide into the atmosphere and then have a parallel system pulling it back out. Just seems like it's never going to really be the cost-effective solution. And it seems like, well, why not just build a good energy system to begin with that doesn't dump the stuff into the atmosphere? And carbon dioxide removal is always an added cost. And are people really going to pay hundreds of billions of dollars to be pulling CO2 out of the atmosphere? So I'm skeptical. Again, I think it's something that should be researched and so on. But I think if the problem is mostly our energy system, let's just focus on building a good energy system.
There is one element in the ocean that anti-nuclear environmentalists are most afraid of, and that is uranium. It is common knowledge in the scientific community that natural radioactivity dwarfs the discharges from the accident at Fukushima by a wide margin. There is another twist to this story. That is the fact that uranium is superabundant in the ocean because, being water-soluble, it is constantly seeping up into our ocean from the Earth's mantle. Is uranium extraction from the oceans economically viable? And given the increasing amount of uranium in seawater, wouldn't such a shift in uranium production qualify nuclear power as being every bit as renewable as wind and solar?
Well, renewable is one of those words like sustainable that people could define to their own liking. So the question of whether something's renewable or just abundant seems to me an irrelevant discussion. I'm not a big expert on this, but my understanding is that there has been substantial progress in seawater extraction of uranium. I think the Japanese have been working on this. I also heard recently that there's work going on with seawater extraction of lithium and other minerals that might be useful for other parts of the energy system. If seawater extraction of uranium proves to be economically viable, that means that fission could power civilization for the long haul. Yeah, and regarding radiation, I mean, probably the radiation that we're most likely to get cancer from is solar radiation. And that's all the sunlight that we get hit with when we go outside. People aren't rational and they respond emotionally strongly to certain words. And I guess the association of nuclear weapons and radiation has just given that term a bad meaning in most people's thinking. But light is a form of radiation, and our eyes couldn't work if there was no such thing as radiation. And so it's just a funny world.
Well, this has been a very interesting discussion. Do you have any parting words for us before you go?
If you think of people in 1900 looking through the 20th century, they wouldn't have predicted the rise of the automobile, aviation, nuclear power, integrated circuits, solar photovoltaics, the resurgence of wind, and they wouldn't have even thought about the climate problem. And yet, when people look ahead through the rest of this century, they kind of extrapolate today as if somehow the technologies that we're going to be using are going to be just like today's technology. And I think this is going to be a century where we're going to see the rise of robotics, and we're going to see all kinds of strange materials. And we need to be thinking about not just how do we deploy the technologies we have today, but how do we keep society flexible and avoid technological lock-in and be ready for these new technologies to transform the world? And I think there's a kind of a Luddite strain that says, oh, we sort of need to go back to some neo-agrarian world and have low energy. But I think with the kinds of population densities that we have and the aspirations that people have to good housing, good medicine and good education and so on, that's going to take a lot of energy to supply, and we need to figure out how we're going to supply that huge amount of energy in an environmentally benign way. And I think nuclear power is one of the leading candidates to do that, and we need to be working to create that future.
Well, thank you so much for being on our podcast, Dr. Caldeira. It's been a real honor and pleasure.
Yeah, thank you.
Thank you.
And now for our final thoughts.
On August 2nd, 1939, a letter written by Leo Szilard and signed by Albert Einstein arrived at the desk of U.S. President Franklin D. Roosevelt. It warned that Germany might develop atomic bombs and suggested that the United States should start its own nuclear program.
74 years later, a similar letter was sent by our guest, Dr. Ken Caldeira, along with Drs. James Hansen, Kerry Emanuel, and Tom Wigley, to policymakers in the ongoing Paris climate negotiations, yet again strongly calling for a renewed nuclear program in the face of a new global threat.
It should go without saying that this emerging threat dwarfs our wildest fantasies of defeat in World War II, and even the most feverish dystopian visions coming out of the anti-nuclear movement.
That threat is clearly outlined in their letter, which states that our failure to act decisively with all the technology at our disposal could severely endanger our collective future, as children would inherit a climate running out of control, severely threatening to plunge our planet into irreversible chaos.
Dr. Caldeira's message today is clear. We stand at the crossroads between an idealized past and an increasingly dark and uncertain future. And yet there is no going back, as our bridges have been burned. We can ill afford to let our fears paralyze us in a time that desperately calls for boldness and action. The only way left is forward.
That's it for our show today. This is Gabe Rick.
And this is Rick Maltese.
We'll be signing off until next time.